The curve C has the equation y equals 3 plus sine 2x over 2 plus cos 2x. Show that dy dx equals this, and find an equation of the tangent to C at the point on C where x is pi over 2. Write transfer in the form y equals ax plus b, where a and b are exact constants. So here's the question then. Let's have a look at this. We've got to get the part A, we've got to differentiate this, haven't we? Get dy dx. It's a quotient, so we use a quotient rule. So here, dy dx then is equal to, it's a quotient, the quotient rule, so it's v, 2 plus cos 2x, more than one term, put a bracket, so it's v, times du dx. Now if we differentiate this, this goes to naught. Sine of something, function of function rule, goes to cos of something, multiplied by the something differentiated, which is 2, so I'll put a 2 in there, minus u, which is 3 plus sine 2x, times dv dx. This goes to naught. Cos goes to minus sine of something. That'll make that a plus. And this will be sine of something. Multiplied by the something differentiated, which is a 2 again. So that's v du minus u dv all over v squared, isn't it? So we've got 2 plus cosine 2x all squared. So let's tidy that up then and see if we get this answer here. So this is equal to then. What do we get? 2 cos 2x plus times 2 is 4 cosine 2x. And then we've got 2 cos squared, haven't we? Plus 2 cosine squared 2x when we expand that bracket. Now this one will have a 2 times a 3 times the sine x. That's 6 sine 2x. And then the second term, sine 2x times 2 is 2 sine squared 2x, all divided by the 2 plus cosine 2x all squared. So we want to make it look like this, don't we? So let's bear that in mind. So, okay, let's put the 6 sine 2x first then, here, plus the 4 cos 2x there, second, in the second place, that's good. Now the third term is this plus this, isn't it? 2 comes outside a bracket and it's sine squared plus cosine squared, which we know is 1, so it's just 2 lots of 1, which is 2, all over 2 plus cosine 2x bracket squared. So there's part A done. Now we turn our attention to part B. Find the equation of the tangent to C at the point on C where x is pi over 2. Write your answer in the form y equals ax plus b. So the tangent of pi over 2, so b at x equals pi over 2, dy dx equals then, put pi over 2 in, sine of pi is naught, so it'll be naught plus cos of pi is minus 1, tap it in the calculator if you need to, pi over 2 times 2 is pi, cos of pi is minus 1, so it's minus 4 plus 2 all over 2 plus, and this is minus 1 again, isn't it? Cos of pi is minus 1 squared. So on the top we get minus 4 plus 2, which is minus 2. Underneath we get 1 squared, which is 1. So this equals minus 2. Okay, so x equals pi over 2. What does y equal? Well, here's our equation for y, isn't it? 3 plus sine 2x over 2 plus cos x. Y equals 3 plus sine 2x, 2 pi over 2, over 2 plus cos x, which is 2x, which is 2 pi over 2. Sine pi is 0, so it's just 3. Cos pi, which this is minus 1. 2 minus 1 is 1. So y equals 3 when x equals pi over 2. So y minus 3, because it goes through this y coordinate here, when it's equal to the x coordinate, equals the gradient, minus 2, times x minus the x coordinate. It goes through pi over 2. There we are then. Now we need to rearrange. So y is equal to minus 2x, isn't it, here, when you expand the bracket. Move the 3 over, plus 3, and then it's going to be plus pi. So minus 2x plus 3 plus pi. And let's see if we've got it in the correct form. Well, a and b are exact constants, yeah? So it doesn't ask us to work it out, but I'll just specify it. A is minus 2 and B is equal to pi plus 3.